Imagine, just for a second, a single camera,
Hmm.
so powerful it can see these amazing cosmic clouds, thousands of light years away.
Right, or even help us finally get a handle on those invisible forces
Well,
that make up most of everything.
exactly. And that's what we're diving into today, the Vera C. Rubin Observatory.
High up in the Andes in Chile, and its core, this absolutely enormous digital camera.
Yeah, a 3,200 megapixel behemoth. They say it's the size of a small car.
Pretty much. And it can image a chunk of sky like 45 times the size of the full moon in one go.
Wow. So our mission today is to look at its first really stunning pictures and this huge 10-year project it's undertaking.
To basically try and unravel some of the biggest mysteries out there in the cosmos.
Okay, let's start with those first images. They're just breathtaking. That cotton candy nebula.
Ah, yes, the Trifid Nebula, about 5,000 light years off, and the Lagoon Nebula, too, a bit closer at 4,000, both in Sagittarius.
And the detail is just unprecedented, isn't it? What makes these images so special?
Well, it's not just one picture. These are composite images. That means they're built up from hundreds of separate shots.
Hundreds. Like how many?
For these ones, it was 678 exposures,
Wow.
taking over 7 hours.
7 hours for one image area.
Yep. That's how you get that incredible depth and clarity. It's not just pretty pictures, though. It
Yeah.
fundamentally changes how we see star birth, how these structures actually evolve.
Right, seeing the dynamics. But, okay, beautiful nebulae aside, Rubin's got a bigger target, something. Well, invisible, right? Dark matter.
That's a huge part of its mission, yes. It's still amazing to think, isn't it? 85% of the universe is this stuff we can't see.
We just know it's there from its gravity, pulling on stars, bending light.
Its gravitational influence, exactly.
So how did we even get onto this idea? Who first suspected this invisible stuff was out there?
Well, it connects directly to the observatory's namesake, Vera Rubin, a real pioneer.
Right, her work back in the 60s.
He's 65, yeah.
Hmm.
She was using this sensitive spectrograph looking at galaxies, and she found something really odd.
Was
Stars way out on the edges of galaxies weren't orbiting slower, like you'd expect. Like planets further from the sun move slower.
Yeah, Kepler's laws. Stuff further out feels less gravity, moves slower.
Exactly. But these stars weren't slowing down. They're moving way too fast, given the visible matter the stars and gas we could account for.
So there had to be something else, something massive and unseen, providing extra gravity.
That was the strong implication, a huge amount of unseen mass. Fritz Zwicky had similar ideas earlier, but Rubin's detailed observations really solidified it. It kind of flipped galactic dynamics on its head.
And now this observatory, named after her, is taking the next step. How's it going to actually pin down this dark matter?
It's going to conduct these massive sky surveys. Over 10 years, it'll map billions, with a B, billions of galaxies.
Okay, billions. But how does mapping galaxies show us the dark matter between them?
It uses a technique called gravitational lensing. You know how massive objects bend the path of light?
It's like a lens, yeah.
Huh.
Einstein's general relativity.
Precisely. So Rubin will measure the tiny distortions in the shapes of distant galaxies. These distortions happen as their light travels past massive structures, including clumps of dark matter, on its way to us.
Ah, so the way the light is bent tells you where the mass is, even the mass you can't see.
That's the core idea. Map the bending, map the mass. By doing this over vast scales, we can chart dark matter's distribution, see how it clumps, how it influences cosmic structure,
So we're moving beyond just knowing it exists to actually mapping it out.
and hopefully getting crucial clues about what it is. That's one of the biggest questions in physics.
Wow. Okay, so beyond the huge invisible stuff, Rubin's also looking at more, well, visible, but packed structures, these globular clusters.
Yes, exactly. Densely packed cities of stars. Like 37 Tucanae, that's the second brightest one in our Milky Way. Millions of stars jammed together.
Millions. How can you possibly see individual stars in something that crowded?
That's what's so impressive. Even with its preliminary camera, Rubin was able to pick out thousands of individual stars in clusters, like 47 Tuc.
Seriously, including ones that are hard to spot, like variable stars.
Yep, variable stars, eclipsing binaries, stars that orbit each other and periodically block each other's light. Finding those in such dense fields shows the camera's power. It proves it can do the job.
And that precision is key for its main mission, right? This 10-year survey.
Absolutely. The Legacy Survey of Space and Time, the LSST, that capability is crucial for measuring individual stars accurately, not just in our galaxy, but in others too.
So tell us more about this decade-long plan. What's the ultimate goal of scanning the sky every night?
The ambition here is huge. For 10 years, night after night, it'll scan the entire visible southern sky. It's building a movie, essentially, a time lapse of the cosmos.
A movie of the universe. What will that show us?
It'll catch things that change. Exploding stars, supernovas flashing across the universe, asteroids moving in our own solar system, maybe even entirely new phenomena.
So tracking changes over time on a massive scale.
Exactly. And that helps us understand things like dark energy, the force accelerating the universe's expansion, and probe the conditions of the early universe. It's about seeing the universe as a dynamic, evolving place.
So for you listening right now, this means we're really standing on the edge of some incredible discoveries.
Yeah, this new eye on the sky, it's poised to pull back the curtain on some really deep cosmic secrets, making the unseen, well, maybe not seen, but understood.
Making the unknown knowable.
You have to wonder, given what we're about to find, what else could be out there? What other hidden wonders, maybe even stranger than dark matter, are waiting?
Makes you think, doesn't it? Keep diving deeper with us into the universe's most captivating phenomena. Subscribe now for weekly space insights.